It's my honor to introduce Dr. Andrew Budson to this crowd. This group has not met, and actually many of my students have not had the fortune of taking your classes over the last few years. They've been taking other things like data science, but it's a real honor to have you here. For those of you who don't know, Andrew is the chief of the cognitive and behavioral neurology and the chief of staff for education at the VA healthcare system. Do you still teach that class that a lot of students used to take?
I haven't for a couple of years.
Yeah, it used to be the class that everybody would take. He's also a professor of neurology at Boston University and a lecturer in neurology at Harvard Medical School. Andrew has published pretty much every key paper we've been reading about dementia and Alzheimer's disease, over 150 papers, 50 reviews for tons and tons of journals. And he's co-authored and edited 8 books, including Memory Loss, Alzheimer's Disease and Dementia, A Practical Guide for Clinicians, 7 Steps to Managing Your Memory, which is translated to Korean and Chinese as well, and 6 Steps to Managing Alzheimer's Disease and Dementia, A Guide for Families. I think these are really amazing books that we've been helping, as I talk to family members, referring these books for people to read. But you're going to talk about a different book.
Well, today I'm going to talk about just this new
paper.
Theory. Yeah, this new paper. Yeah,
great.
Absolutely.
So without further ado, I'll let Andrew sort of explain the background for that paper. And thanks for coming today.
Yeah, no, so it is a pleasure to talk about this paper. It came about when I was working with my colleague that you can see here, Elizabeth Kensinger, and we were writing this new book called Why We Forget and How to Remember Better, the Science Behind Memory. And we started diving into the research on all of these different memory systems and what's been known about them, over the last 10, 20 years. And at the same time, it was also one of Elizabeth's suggestion that I read a book that's been on my to-do list for a very long time, but I had never read, which is William James' Principles of Psychology. And that turns out is really an inquiry into consciousness, which is something I had been interested in since high school, so for an extremely long time. And it was sort of the conjunction of sort of the new theories of memory with this sort of older inquiry into consciousness that led to this theory. And then I got my friend and colleague from college, Ken Richmond, who is a philosopher, to join as well and help to shore up some of the work here. So let's dive into this. So when you think about consciousness, some of the questions that come up are, why did it develop? What does it do? What is it good for? And the other thing that's sort of interesting about consciousness is it's difficult to control. So anyone who has practiced mindfulness or given it a try knows it's actually not so easy. And another thing that's sort of interesting about consciousness is if our actions are under our conscious control, so why is it that dieting and resisting other urges are so difficult? Can you do complicated types of activities like driving without conscious awareness? Are animals conscious? And are there disorders of consciousness, neurologic disorders, psychiatric disorders, developmental disorders of consciousness? And William James talks about the way consciousness feels, like this sort of continuous stream with their sort of present now that's sort of swirling around our feet. And then there's things upstream in the future that's rushing toward us, and then the past downstream rushing away from us. So why does it feel like that? Because we know the brain is actually processing massive amounts of information in parallel. The brain doesn't really work in this linear fashion that subjectively is how it experiences. So the question is, well, does consciousness really flow linearly with time? And William James actually talks about the fact that there's evidence that consciousness does not flow linearly with time. He talks about this quotation from Exner, which is that when we are deeply absorbed in something, whether it's writing or talking with a friend, we don't hear the clock striking, but we can have our attention awake after the clock has finished striking, and we can count off the strokes. So the question is, were we conscious of the clock striking or not? And we all have this experience when we're at a cocktail party, which I think is really the same phenomena, where you hear your name spoken and suddenly you're able to be conscious and recall what was said in the earlier part of that sentence where your name was spoken, even though you weren't paying attention to it before. So were you conscious at the time or not? And this brings up scientifically these effects that are so-called post-dictive, right? So a predictive event is when you're predicting things into the future. A post-dictive event is when things are going the other direction, happening in the past. And this is when a later stimulus can affect the perception of an earlier stimulus. And in psychology, we're all very familiar with this phenomenon. So backwards masking is essentially a post-dictive effect. If you show in this experiment the face alone, even for just a few milliseconds, you'll see it. But then when there's a mask afterwards, then you don't see the face. There's other experiments that also take advantage of the fact that these later events affect earlier perceptions. If you have a red disc presented for 20 milliseconds, you see a red disc. But then you show the disc for 20 milliseconds followed by a green disc for 20 milliseconds, you'll see a fused yellow disc. And there's this very cool effect that's been known for about 50 years called the color phi effect. And this is if you have a red dot, say, at the bottom of the screen, and then there's a little lag, and then you have a blue dot at the top of the screen, you do not perceive the red dot at the bottom and the blue dot at the top. What you actually perceive is the red dot is moving, and it changes halfway through and then ends up as a blue dot. You know, how is this possible that this happens? And it also brings up something that we have all taken for granted for the last 100 years, which is, how is it that single frames of a movie, that if you showed any of them individually for the amount of milliseconds that they're on the screen, you would be able to see the distinct image. But yet when you put them together, you don't see flickering images. You see smooth, continuous motion. Why is that? Now, these effects don't only occur in the visual domain, they can occur in other sensory domains as well. The illusory rabbit comes about if people tap 5 times at the wrist, 3 times at the elbow, 2 times at the shoulder in rapid succession. And what you perceive is not these separate taps, but you perceive a little animal that feels like it's running up your arm. There's other fascinating things about consciousness that need to be explained, and one of them is illustrated in this nice experiment, where if you have a target number that is sometimes present, sometimes not, a variable delay, and then a mask that appears around that number, your brain actually is able to distinguish in this early phase, just after 200 milliseconds, it can distinguish whether or not there was a target there or there was not a target there. But the conscious perception may or may not be present. You know, so what is going on there? And these important effects of consciousness are not only there with sensory perceptions, but also is important in decisions and actions. So in this famous experiment by Libet that was conducted more than 25, 30 years ago, he had people decide to make an action. And whenever they decided, they were supposed to note the time that they made that decision on a special clock. And so they may say, this is the conscious decision to move. But what Libet found is that the motor potentials in the frontal lobes were already preparing to make that move before the conscious decision was made. There's also this fascinating phenomenon that's called chronostasis. Now, we all know that if you want to look, say, from one side of the room to the other, we can make a saccade. We can keep our head still and just move our eyes. Now, if you did this with your phone and you had a picture here and on the video and you wanted to then move it over there, you would see a blur, right? You hold the phone here, then you move it, and then over here, or you just turn it, there'd be a blur. But when we make a saccade, we do not see a blur. The reason we don't see a blur is that, as shown in this bottom panel here, what happens is the perception of where we end up fixating after we make the saccade is projected backwards in time and fills up the space when we should have had that blur. And it's called chronostasis because it seems, if you look at a clock, that the second hand is actually present in the same spot for 2 seconds or 1.5 seconds. There's also another experiment that Libet did when he either stimulated the hand directly or the finger, or he stimulated the sensory cortex of the finger area. And 2 very interesting findings were noted. One is that it took about 500 milliseconds of stimulation for the sensation to be consciously felt in either place, which is a very, very long time. The second fascinating thing is that from the subject's perspective, the stimulus occurred at the time when it began. So it somehow was referred backwards in time for 500 milliseconds. Another thing about consciousness is that, as we've just discussed, it takes a long time for these perceptions to occur, takes a long time for motor actions to occur. And it's absolutely not possible that people can do fast events like hitting baseballs, playing improvisational pieces for musical instruments, doing martial arts activities, other sports and athletical activities that can possibly be consciously controlled. It's all happening too fast. We know that there are patients that have damage to their brain and do not have adequate perceptions. So individuals with so-called blind sight are blind in one area of their visual field, so they can't consciously see anything. But if you ask them to guess or just point to where they think a stimulus is, it's way above chance. And in this particular experiment, this patient here, D, who has a visual perceptive agnosia, when she's asked to match this little card to the slot, she's almost at chance of trying to match it up. But when she's asked to just simply put it through the slot, she's able to do it. And this type of dissociation between perception and action can also be seen in healthy individuals when given optical illusions like these Titchener circles, where people have to gauge how big they should make their hands. And when they just gauge how big they should make their fingers to pick up the disc, they get it wrong. But if they're just simply asked to pick the disc up, their finger goes to the right ratio. So how is it that consciousness contributes to evolutionary success? It's taking place after the perception, decision, and action. It's too slow to participate in many real-time events. It fools us by creating these visual and tactile illusions. We know that these judgments and actions can occur without conscious perception. And consciousness is difficult to control, which is very odd if the purpose of consciousness was to help us perform intentional action. So what does it do? How does it contribute to evolutionary success? And the answer that I came up with my colleagues is that consciousness is really a memory system. Now, it was Endel Tulving that told us that episodic memory is our processes that allow us to mentally time travel backwards and to re-experience a moment in time. And we argue that consciousness developed to allow encoding, consolidation, and retrieval of episodic memory to take place. It's consciousness that's actually binding the elements of an experience together, because in terms of the actual neural processes, these things are different. Color actually precedes motion in the nervous system. Addition precedes vision, but we perceive it as a bound whole. It provides a medium to replay memory traces. Now, we've known for more than 10 years that the purpose of episodic memory is not actually to remember things from the past. The purpose of episodic memory is to use prior information to flexibly, creatively plan for the future. And so we argue that because consciousness is really the same as episodic memory and these other explicit memory systems like working memory, semantic memory, sensory memory, that's what the purpose of consciousness is. It's to help us use memory to flexibly plan for the future. So let me give you an example of what I mean. So let's say you hear a dog barking through your sensory memory. Well, that sensory memory gets transferred to your working memory, and that pulls up an episodic memory when you remember that the same dog that you're hearing barking chased you off its property. So when we retrieve that memory, it's very easy to imagine the future, that the dog is probably going to chase us again. So, but why is consciousness important? And for that matter, why is episodic memory important? You know, can't you just see the dog and let operant conditioning and other implicit memory systems lead you to walk across the street? Well, consciousness, we argue, is necessary to remember the event using episodic memory. Well, why is that important? Well, the stimulus and the setting may be similar enough for operant conditioning to trigger the response, but maybe it's not similar enough for the operant conditioning to trigger the response. Or maybe the conditioned response is triggered, but the situation requires us to choose a different action, one that was not part of our conditioning. So this is supported by the fact that our ability to imagine things is constrained and related to our episodic memory. Now, consciousness is certainly also involved with other things today, problem solving, abstract reasoning, language, but we argue that these functions developed later in evolutionary history. So, for example, let's say that you have a memory of going to pick berries outside a cave. Okay, well, that's great, but you also have a memory that you were by the same cave and you were chased by a bear. And the problem solving comes in when you have these two different possible future outcomes. One, when you were able to pick the berries and you were successful. The other is when you went to pick the berries and you were chased away by the bear. Once you have these both in mind, you can work to problem solve to bring about the future you want and avoid the future that you don't want. And language, we argue, comes in because, you know, once you have a whole bunch of different bears, general concepts of bears or general concepts of berries can occur. And when you're trying to communicate with your friend, to have them come with you to go to the cave to distract the bear while the other person picks the berries, then language is going to develop. All right. So maybe I've convinced you by now that consciousness evolved as part of the episodic memory system. But how does this knowledge help us to understand consciousness anymore? So the idea is that if consciousness evolved as part of the explicit memory system, as part of a system that allows us to store experiences and retrieve them so we can flexibly, creatively plan for the future, there's no need that consciousness needs to operate in real time. If it's a memory system, there's no reason it can't function properly with a small delay. And because of this, what we argue is that our conscious perception is actually a memory. So we're not directly perceiving the world. We are remembering a perception of the world. We essentially experience the world by remembering sensory memories. But of course, we know that we're not experiencing these sensory memories directly, right? The experience is a mashup between these bottom-up sensory processes and these top-down episodic and semantic memory processes, okay? So that our conscious perception is this mashup, and that's what we are remembering. So once we can wrap our head around the fact that our perceptions are actually memories and they're not actually perceiving things in real time, then there's no problem with being able to count off the strikes of the clock after it occurred. It's no problem with us being able to remember the earlier part of the sentence when we hear our names. All those postdictive effects that I mentioned are no problem. It's no problem that there's a distinction between the actual bottom-up sensory processes that's happening shortly after 200 milliseconds and the conscious perception that's occurring between 300 and 400 milliseconds. There's no problem with the fact that when we have a saccade to somewhere else in the room, the final image on the saccade is projected backwards in time because we're simply remembering it. It's no problem that our sensations are being referred backwards in time by 500 milliseconds. That is what memory does. All right, so now you understand perceptions. Now, what about decisions and actions? So we argue that the you who decides and acts is actually unconscious. So your conscious decisions and conscious actions are actually memories of those unconscious decisions and actions. And if that's the case, if you are remembering your conscious decisions, this explains the Libet experiment, where your preparing to move occurs earlier than your conscious decision to move, because your conscious decision to move is you remembering your unconscious decision. And this explains how all these sort of sports and music events go on in real time. They're all happening unconsciously. And then we consciously remember that we did all these things. So the you who decides and acts is unconscious. But does that mean that we never use our conscious mind to make decisions and to guide actions? And my answer is no, not at all. We absolutely use our conscious minds for decisions and actions. And I'm going to give you an example building on the work by Kahneman and Tversky. So they also noted that there's two different systems that human beings can use to make decisions and decide on actions. One of them is unconscious, system one, intuition and instinct, and most of our decisions and actions, as indicated by this 95%, most of our decisions and actions occur with this system one, according to their model. But we also have this system two, that is what is involved with rational, conscious thinking. And this is what we believe is the conscious memory system. It's the same thing. So I've already previously equated consciousness with this explicit memory system. Now we're also adding the system two by Kahneman and Tversky onto this. So let's say that you want to go and get a drink of water. I would argue that if you are just simply engaged in working on your computer, you decide you want to get a drink of water, all the steps involved in getting that drink of water can be done unconsciously. And you certainly will be consciously aware that they're happening, but you don't need your consciousness to direct you to do that. You don't need your consciousness to decide exactly how much you should put your foot forward before you set it down on the floor. You don't decide how much force you need to put your hand on the knob or to pull the door open. All of that occurs, system one, all of that occurs unconsciously. But suppose the situation is different and you're in an arena like Katniss Everdeen, and you're trying to get a glass of water, but to do it, you have to either go through a field of poisonous snakes, or you have to jump from lava rock to lava rock. And even once you make it across, you have to contort your hand in an unusual way to get it through barbed wire to get at the water that you're looking for. In this situation, you are absolutely going to be using every part of your conscious abilities, your episodic memory to remember how you last did when you had to jump from one lava rock to another. You're using your semantic memory knowledge of different snakes and how fast they're going to bite you and what you have to do if you get bitten. You're going to have to think consciously of how you're going to contort your hand so it's not ripped to shreds. You're going to be consciously thinking and using system two to make this decision. So anytime you have difficult decisions and actions, you're going to be using the conscious memory system, using this system number two. And if we think about the fact that consciousness is a memory system, and it's to help us remember things and plan for complicated decisions and actions, now we understand better why it's difficult to control, because that's not what it developed to do. Now, I talked earlier about William James noting that consciousness feels like this continuous stream, even though we're processing information in parallel processes. So the question is, well, why does it feel like that? And we argue that the reason consciousness feels like a stream is because it's a memory system, and that's what our memory does. It timestamps things and puts them in this logical order so that we can understand it. And once we're sort of decoupling sensory input from consciousness, there's no reason the two need to be followed in the same way. Now, why is it that consciousness is time-stamping things in order? Well, we think that the reason it developed this is to allow us to flexibly, creatively imagine different possible future outcomes and sort of move around these different scenes and scenarios, just like you're a movie director, moving scenes around on a storyboard. And we feel that this explains some of the intuitive feelings that we have about consciousness. I don't know if anybody has ever sort of felt you're sort of in the Cartesian theater, sort of watching things go on. This is, of course, the metaphor of Plato's cave, where he suggests that we don't have direct access to reality. We only see shadows projected on a wall. And of course, you can use the more modern analogy, which is really the same thing of the movie The Matrix, that again, we're not directly experiencing reality, we're experiencing a simulation. And I want to bring up another analogy that I think helps to explain how our actions and decisions work. And I think of the whole brain as a horse and a rider together. I think about the horse as our system 1 unconscious brain processes. And I think about the rider as our system 2 conscious mind. And the horse is in control of all the moment-to-moment decisions. The human rider is mainly just going along for a ride. You know, you don't need to tell a horse how to move their feet, to go across a rocky field, to jump over a stump. The horse does that all automatically. But the rider can give either momentary or general instructions, and the horse is usually happy to oblige that. The rider can, of course, see if the instructions were followed about 500 milliseconds later, but the horse is ultimately in control. Now, why is it that the rider does any better than the horse? The rider has these special built-in sunglasses, and the rider can use these special sunglasses to look out at the world, although there is a 500 millisecond delay, and that's what sensory memory is. They can access prior autobiographical events through episodic memory. They can access prior information from semantic memory, and they can keep information on the screen and manipulating it using working memory to flexibly, creatively imagine different possible future outcomes. So that is why the rider has these powerful abilities and why the rider will sometimes be directing the horse. But there's one more thing. The images are coming from the horse. It's the horse that decides what images the rider is going to be seeing. And this is why mindfulness is so hard, because it's the horse that's deciding on the images. All right, so to just sum up this section, we use both system 1 and system 2, both our unconscious brain processes and our conscious mind to make our decisions and actions. We could make decisions and actions with just system 1 horse only, but, you know, and that might be good to get the horse from the watering hole, you know, back to the pasture, but that's not going to be able to get the horse from Carson City to San Francisco. For something like that, you're going to need to use your conscious system to do it. Now, I just want to briefly talk about the neuroanatomical correlates and localization for this. So basically, if consciousness is the same as explicit memory, the neuroanatomical correlates of consciousness are going to be the same as the neuroanatomical correlates of explicit memory. So what are the neuroanatomical correlates of explicit memory? Well, for episodic memory, there's hippocampus, there's Pape circuit, there's also the default mode network. For semantic memory, there's inferior lateral temporal cortex. For working memory, there's frontal and parietal cortex. But is there any more? Well, in this wonderful book by Murray, Wise, Baldwin, and Graham, they argue that every cortical area contributes to memory, each in its own specialized way. And I think that that's exactly right. Visual areas in occipital cortex are important for visual consciousness and imagery. Auditory cortex is important for auditory consciousness. Parietal cortex, important for awareness of space. Somatosensory cortex, important for tactile and other forms of sensation consciousness. Even primary motor cortex is important for being conscious of fine motor movements, et cetera, et cetera, et cetera. So all these areas, they're all important for different types of consciousness. And this is another sort of nuance that we have put into this paper. We don't think it makes sense to talk about consciousness as like a single thing. We think there's different aspects of consciousness. We think that all cortical areas support it, but none are critical. Damage to one type of cortex disrupts or abolishes one type of consciousness while leaving others intact. And I'm sure that Swathi and any of you others who have worked with patients who've had strokes or traumatic brain injuries, and what I see in my clinic of patients with dementia, I see this every day. Subcortical structures are definitely necessary for consciousness, but I don't think they're sufficient. I don't think they have the cortical architecture that is necessary. I also don't think that there's like one area of consciousness that is sort of the hub. I think that any cortical region is sufficient in and of itself of producing conscious thought. But I do think there are subcortical structures that probably help to figure out, are you processing visually conscious? Are you processing sensory conscious, these different aspects of consciousness? Okay, in the remainder of my talk, I want to just talk about some implications, and I promise I will leave time for questions. So, are animals conscious? And if so, which ones and how do you know? And what we argue is that because all vertebrates have hippocampus and cortex or analogous structure, that all vertebrates have the requisite neuroanatomy for consciousness. So I think they're all conscious. This fits with other researchers who suggest there's a gradient of consciousness. I think the consciousness of a fish is different than that of a frog, which is different than that of a mouse, which is different than that of a dog, of a chimpanzee and a human, but I think it's on a continuum. And I do want to say, this doesn't mean that animals without a backbone are unconscious. It just simply means that our theory doesn't have anything to say about it. Okay, that's all it means. But I do think because we argue that vertebrates are conscious, we should at least consider, sort of as a species, we should consider, the ethical implications of consuming vertebrates which are conscious. So, if cortical regions are the areas that are conscious, there are many neurologic disorders that are actually disorders of consciousness. So as I mentioned, strokes, traumatic brain injuries, other disorders that cause cortical lesions are disorders of consciousness. Alzheimer's disease, other cortical dementias are disorders of consciousness. We actually argue that delirium is an example of people who are awake but unconscious. And I think the more you think about delirium, the activities that people engage in when they're delirious, I think it makes sense that that's what it is. Migrainous phenomena are cortical phenomena. They disrupt consciousness. Epilepsy, of course, is cortical phenomenon, disrupts consciousness. I think there are psychiatric disorders of consciousness. The two that I feel are most straightforward are the dissociative disorders and schizophrenia. I actually think they're developmental disorders of consciousness. And in fact, part of this theory came about in my thinking about my own son, who is now 22 years old, but has severe classic Kanner autism. And he and other children like him learn through operant conditioning. They don't learn in the typical episodic memory leads to semantic memory, leads to language. They learn in a different way. I think it's a disruption of consciousness. Now, I want to point out that not only are there disorders of consciousness, but even the way that we all experience the world as neurotypical individuals this theory has a lot of implications for. So I might be able to convince you that if you are going through your morning routine, you're mainly using your system one, that when you're brushing your teeth, you're not consciously thinking about exactly what you're doing. When you're showering, it's all happening automatically and unconsciously, which is why you can think about different things while you're doing these activities. But what about in a different situation, like if you're in a meeting? Are you always in conscious control of what's going on there? Well, if you're like me, sometimes you'll notice that what you say in a meeting or when talking with friends is not actually, what you had expected to say. And you might find that you're somewhat surprised about it. And then when you ask yourself, now why did I come up with that? Why did I say that? You might be right, but you might actually be wrong. Now, why do I say you could possibly be wrong? Well, I want to pull in some of the wonderful work by Michael Gazzaniga with his split brain patients that has led him to talk about the left hemisphere as the conscious interpreter. So in the classic experiment that is most cited in the literature, he has patients who have their corpus callosum severed to help reduce the spread of epilepsy from one hemisphere to the other. And he flashes an image to the right side of the visual world, which projects to the left cortex. And he then asks the person to point to the most relevant image, and the left hemisphere, of course, controls the right hand. They point to the image of the chicken. No problem. Now, flashed quickly in the left visual field is a snowy scene, and this projects to the right nonverbal hemisphere, which controls the left hand. The left hand points to the shovel. So far, so good. But then the individual is asked, why are you pointing to the shovel? The left hemisphere, not having access in this split brain patient to the information that the right hemisphere is seeing, says, well, you need a shovel to clean out the chicken coop, right? So it's a plausible answer, but it's the wrong answer. It's not the right answer. Unless you think, well, fine, that's with a split brain patient, but that wouldn't happen to me. It has been known now for over 50 years that people are often unaware of stimuli that influence their responses, or they're unaware that they've made a response, or they're unaware that the stimulus affected their response. And Peter Carruthers actually has an entire book arguing quite convincingly, in my views, that we are not actually aware of our own internal mental processes any more than we're aware of anybody else's. And we actually have to use those same tools that we use to interpret other people's mental states to interpret our own. And I think that this understanding really helps us to explain why people have difficulty controlling their behavior. I don't know if anybody else has ever experienced it, but sometimes I may be doing something and I'm saying to myself, I shouldn't be doing this, but yet I find myself still doing it. Now, am I saying that you're not in control of your behavior? My answer is no, that's not what I'm saying at all. Okay, because you are both your conscious mind and your unconscious brain processes. It's still you. So of course you are in control of your actions and your behaviors. It's just not always your conscious mind that's in control of them. I would note that actually when people interact with you, they're interacting with your actions and your habits and your decisions, which 95% of the time are being made by your unconscious brain. So people are actually interacting with your unconscious brain all the time. Because as a conscious being, you think about yourself as a conscious mind, you actually think of yourself as something a little bit different from what the rest of the world is thinking of yourself. Now, I want to be very clear that this theory actually really says nothing about free will in terms of determinism on a microscopic scale. It's just, this theory is agnostic in terms of whether, everything is determined by, stimulus response interactions and physical and chemical interactions in the brain interacting with the environment. It's agnostic on that. But I do want to be very clear that if we put that one sort of determinism issue aside, your conscious mind can absolutely still impact your ability to make the best decisions and actions. And all you need to do to involve your conscious mind in making a decision and action is to give yourself time to make the decisions and actions, and use all the conscious tools that you have available to yourself. So if you're deciding an important decision, write down the pros and cons, talk with a friend. You can make a conscious decision all the time. You just have to give yourself time, be deliberative, be rational, be logical, and you can do it. We can also use our conscious mind to change our unconscious brain processes and the habits and the traits that we have. All you have to do is be aware of it, make a decision, and use your conscious mind to use these strategies to make changes. That's essentially what cognitive behavioral therapy is, right? I'm not saying this is anything new. We've known this for a long time. This theory just helps put a framework around why this is so important. I think it's important for teaching ethics, and it has the obvious implication that if we're going to be able to teach ethics, we have to teach not only the conscious mind, but also the unconscious brain. How does the unconscious brain learn? It learns by doing. It learns by role plays, other examples, being in situations. That's how it learns. It doesn't learn from a textbook. So if we're going to be teaching things that we want our unconscious brain to understand, it has to be done. It can't just be verbally explained. I think this helps us to understand hurtful actions, but I want to be very clear. I don't think this theory in any way excuses them. Everyone has to be able to tame their horse. You can work on controlling your thoughts and improving your conscious mind by practicing mindfulness. And once you have better control over your thoughts, essentially you're training the horse what you want to be giving you, then you can make these changes. You can tap into the power of your unconscious self. You can use sleep. You can bring unconscious processes to your conscious awareness. You can tap into your unconscious biases and stereotypes. And you can be in the zone where you're really letting your unconscious brain processes have full reign. And I think that many top athletes and musicians use both their conscious mind and their unconscious brain to their full potential. I also think the combination of unconscious brain processes and conscious mind is one of the ways that some of our greatest and most creative insights have occurred, not only in art and aesthetics, but also in science and in the clinical world. So thanks so much for listening to this new theory that we've been working on. And looks like I have about 8 minutes for questions. So maybe we can start in the room with any questions.
That was fabulous. There are some questions online, so maybe we can let
Sure.
people mute themselves and ask, and then people can formulate questions here.
So it looks like So Andreas has a question that says, can this process be manipulated pharmacologically? And thank you, Andreas, because it's actually, oops, I hit the wrong button there. It's one of the,
less is more.
sorry,
Believe more.
I accidentally,
Look out for Massachusetts with more.
sorry about that.
Most of us think we're pretty observant, but with a bit of mind control.
I accidentally clicked the wrong button here. So I do think we can pharmacologically manipulate these things. In fact, one of the things that we're interested in doing is to see if we can use medications that can disrupt either explicit memory or consciousness, and to see if that disrupts the other. So I definitely think that we might be able to do that. Now, are there sort of some neurotransmitters that would affect conscious processes or unconscious processes, not the other? I think it might be, absolutely might be. Other questions? Yeah, and so feel free, you can unmute and shout out. David Summers says, can you speak to information capacity of conscious experience? Perceptual working memory, other forms have notoriously low capacities. Yeah, I mean, there are a lot of people who have talked about this. The working memory capacity traditionally has been felt to be the magical number 7, but it turns out that the reason it's 7 is because it's really, you can chunk 7 digits into 3 to 4, and we really think it's 3 to 4 that is the actual capacity of working memory. And you know, I think, as I'm thinking about this, and I haven't thought about this particular question that you're asking before, but I mean, maybe it's the fact that consciousness is memory that's one of the reasons that it doesn't feel so tiny. You know, to be clear, you know, many people have suggested that consciousness is the same thing as working memory for a long time. What I'm saying is the same thing as all forms of memory, including episodic memory. And I think we can get away from at least the way it feels to us, like it's only 4 items large because of that. I hope that makes sense. Happy to think more about that with you.
Can I ask a question?
Yeah.
I don't know if people can hear me, but you may have to speak to it. So this notion about all brain regions are involved in conscious memory is really intriguing, especially for areas like Broca's area involved in speech planning. So do you think that delay of, you said 500 milliseconds, whatever that is, does that apply to all brain regions in that they hold something in place? And what you see in something like stroke is the erosion of that ability to hold information?
Yeah, no, I mean, I think you're right. So one thing I should definitely say is I absolutely believe that the cortex does more than just conscious processing. The cortex certainly does unconscious processing as well. But in terms of speech, I think that you can speak consciously, and I think you can speak unconsciously. So I don't know if anyone else here has the experience as a teacher that you are sometimes talking and you're giving a talk you have given many times before, and you suddenly find yourself daydreaming and thinking about some other task, something you have to do later on, and you're looking at the slide, and all of a sudden you're not sure whether you have already talked about this slide or not.
Actually, that's exactly what I'm saying. That's really well said. I'm saying that in Broca's aphasia, it's like the opposite extreme of that, where every easy speech is so hard.
Right.
Now you have to put everything into focus.
You have to put conscious effort into every little bit of it. No, I think so. And the other thing that I think in terms of speech and this conscious delay is, I don't know if anyone, I'm sure other people have had this experience that I've had, where, you know, sometimes you're talking with a friend and the conversation goes very easily and quickly, and it's not difficult to contribute to the conversation, say in a group of people. Other times you're trying to get this point in that you're dying to make, and you always feel like you're a half a beat behind. And when you start to talk, it's like somebody else is already talking. And I wonder, it's like, is the reason we have this experience is because when we're dying to get this point in, we're really doing it consciously, and it has that built-in sensory delay and action delay. But when we just relax and don't try to make the effort and just let it happen, then it's unconsciously happening. Yes, question.
Behavioral therapies or interventions for consciousness, like how do people improve their system 1 conscious brain, or sorry, system 2 conscious mind? Because you said like 95% is unconscious.
Yeah.
5%. Is there a way to enhance or kind of shift the scales relative to acting?
Absolutely right. I mean, so I mean the two ways that this is currently being done is, one is it's being done using mindfulness. So the more mindful you are, the more you're consciously directing your decisions and actions. The second is cognitive behavioral therapy. So the whole idea is that for the unconscious system 1, you need to use role-playing action activities. But for system 2, you can educate system 2 through conscious activities like reading, discussing things, all of those will enhance system 2. So I actually do think it's already being done. We just haven't sort of thought of it with this sort of framework around it.